Alright, so let's do 5x plus 2 as a 2x plus 14. This should be a review for us. Shouldn't be too bad. So I've got variables on both sides of my equation. So what should I do first? If I want to bring those variables to one side, what would I do? Yeah, Will, what do you got, buddy? Okay, I would subtract 2x. Could I have done something different? Jay, could I have done something different? What else could I have done? Right, I could have done that as well. So I have lots of options, but each of these are equivalent statements, right? So 5x take away 2x, that gives me 3x. I still have a positive 2, and that's still worth 14 on the other side, okay? Next idea, what should we do? Subtract 2, I'm with you. We're going to subtract 2 from both sides for another equivalent statement. So I'm going to get 3x is now worth 12. We're going to divide by 3. We're going to get a value that x is then equal to 4. Okay, is this pretty straightforward now? All right, good. Okay, in your groups, try this problem out. Talk to each other. It's a you try. So make some noise, ask some questions, and then we'll see how you do at the end here, okay? All right, it sounds like everyone's getting 5 for an answer, right? Can someone walk me through it really quickly? Yeah, Evan, go for it, buddy. What'd you do?
So I distributed both sides.
Okay.
10x
Yep.
minus 2 equals 3x plus 33.
Mm-hmm.
And then I subtracted 3x from both sides, and I got 7x minus 2 equals 33. And then I added 2 to both sides, and I got 7x equals 35. And I divided both sides by 7, and I got x equals 5.
You got x equals 5. Did everyone do the exact same thing pretty much? Straightforward? Is Evan correct? I think it's correct too. Absolutely perfect. Nicely done. Okay, a literal equation, the definition for us that we've probably seen these before, a literal equation is nothing more than this. It is an equation, and I'm going to abbreviate equation as EQ. It's an equation with 2 or more variables. 2 or more variables. So that's the definition that we're going to be working with. A literal equation is an equation with 2 or more variables. Here is an example of a literal equation. I'll do it in green for you. A is equal to pi r squared. Now, why is this a literal equation? You can just shout it out. You don't have to raise your hand. Just shout it out. What is it? Talk to me. It's got 2 variables, okay? A, this stands for area. R, this stands for radius, right? This is the area of a circle. Area of a circle is pi r squared. There, right there, these are my 2 variables, right? Does everyone understand what a literal equation is now? Can you give me another one? Can you think of one off the top of your head? Y equals mx plus b, right? There's another one, right? Y equals mx plus b. We're going to get into that later on in this 24 days. What else? Give me another one. Anything. Y equals ax plus c, right? There's another one, right? Or how about circumference equals pi times diameter? You guys know that one from geometry? Or you haven't taken geometry yet, but you're getting there, right? You've seen it before. Okay, so a literal equation is an equation with 2 or more variables. Okay, so what are we going to be doing with these things? We're going to be solving for one of the variables inside a literal equation. Or solving for one of the variables, okay? So let me give you an example. Here's example number 1, all right? So if I have ax minus bx is equal to c, and I want to solve for the x variable. So a is a variable, b is a different variable, c is a different variable, and x is a variable, right? Well, I've got all kinds of things going on here. So some people might consider the a, the b, and the c as constants. We don't exactly know because we don't know what this stands for. But in this case, I want to solve for x, okay? But I just know that a and b are different. So I can't say ax minus bx. I can't combine those yet, right? There's something that I have to do instead. Does anyone see what I could do in both of those things? Thoughts there? Jay, what do you think, buddy?
You could take x out, and then you could say x parentheses a minus b equals c.
There you go. You're on the right track. So notice that this term right here, this term has an x in it, and this term, they both have an x in it. You guys agree with that? They both have an x. So if they both have an x in it, I can do what's known as taking an x out, or I can factor out an x. We're going to get more into that, but that's what we're doing. And all it would be is this. If I take an x out, notice that I would just have a minus b is equal to c. Notice that all we did was the distributive property in reverse. Yeah, see that? That's all we did. We did the distributive property in reverse, okay? Because if I gave you x times a minus b, well, everyone would then just go, well, that's x times a minus an x times b. Well, that's exactly what our original problem says, right? So look, I have x multiplied by the term of a minus b is now equal to c. Does that make sense so far, my first step? Okay, if I want to solve for x, what would I do? You can just shout it out.
Divide by a minus b.
We would just divide by the quantity of a minus b. There we go. It would divide by a minus b. Good. Both sides. Divide by a minus b. So I'll get this. X is equal to c divided by a minus b. And notice my literal equation has now been solved for x. Okay, so check it out. I have the volume is equal to 1/3 pi r squared h. This is the volume of a sphere. 1/3 pi r squared h, okay? And I want to solve for h. All right, this may look really complicated, but it's actually pretty simple, right? So check this out. I am taking the 1/3, I'm multiplying it by pi, I'm multiplying it by r squared, and then I'm multiplying by h. So notice everything on the right-hand side is being multiplied by, let's just multiply it, right? We're not adding, we're not subtracting, we're not dividing. So if I want to solve this for h, check it out. All I got to do is divide by 1/3 pi r squared on both sides. Divide by 1/3 pi r squared. Does that make sense so far? So here I have. I have v over 1/3 pi r squared is equal to h. But you know what? There's one more little tiny step that I can do. Does anybody see it? One more little tiny step. It has something to do with that fraction. Daniel, do you see it?
Flip the 1/3.
Yes, flip the 1/3. Why?
Because if you move it up to the numerator, it's like the same thing.
Yeah, so check this out. If I have v divided by 1/3, right? So that's the same thing as saying 3v over pi r squared is equal to h. So this is the answer that you would find in the back of the book. Okay, everybody, so check this out. This is the way that we convert Celsius and Fahrenheit. Right? There's two different ways of measuring temperature, Celsius and Fahrenheit. So Celsius is equal to 5/9 the quantity of Fahrenheit minus 32. I'm wondering, can you, in your groups, solve that for F? Ready, set, go. Okay, so this one seemed like it gave you guys a little bit of a trouble, so let's talk about it, right? So the first thing that we decided to do was divide by 5/9. So we're going to divide by 5/9. So that's on the bottom. So if I have c divided by 5/9, we just realized that we could write that as 9c over 5, right? Because I flipped the bottom one and multiply. That will give me 9c over 5. Does everyone agree with that move there? So notice that 5/9 and 5/9 reduced to 1. So all I have left with over here is just f minus 32. So what's my next move? What do I got to do? All I got to do is add 32 to both sides. Add 32 to both sides. Well, how do I rewrite this? This is just rewrite what it says. 9c over 5 plus 32 is worth f, and you have completed the task. Not bad, right? Okay, so I got 3 vocab words that we got to talk about. Make sure we all understand, because we're going to be using these as we go, okay? The word ratio. The word ratio. Who's got a pretty straightforward definition for the word ratio? Just shout out. What do we got? There you go. Okay, so it compares two numbers by what? By, you said fraction, so what's another word for fraction? There's division, right? That's what I was going for. So it compares two numbers by division. That's a ratio. A comparison of two numbers by division, okay? Then what's a unit rate? Okay, you're on the right track. So a unit rate is nothing more, is a rate with a denominator. Oh, not rate, sorry, ratio. R-A-T-I-O. Okay? It's a ratio with a denominator that's equal to what? That's equal to 1. So that's what a unit rate is, right? So a ratio is a comparison of two numbers by division, like 1/3, right? That's a ratio. A unit rate is a ratio where the denominator is 1. So it's a unit, right? So, we have like 60 seconds per 1 minute. So that would be a unit rate, right? 60 seconds per 1 minute. That's a ratio where the denominator is 1. Does that make sense? Okay, so then a rate is a ratio. It's a ratio that compares quantities. So I abbreviate that. Quantities measured. All right. Or is that a ratio that compares quantities measured in different units. Different units. All right, so a ratio, back to the top. So a ratio is a comparison of two numbers by division. The unit rate is the ratio where the denominator is equal, like 60 seconds per 1 minute, right? A regular rate is a ratio that compares two quantities but in different units, like miles per hour, right? So we have miles and then we have hours. So that's what our rate is, all right? So our rate is measured in miles per hour or such and such, okay? So we're going to be doing some examples where we're going to be converting from one to the other, all right? All right, so check this out. We are being asked to find the best deal. Okay, option 1 is you get $25 for 2 shirts. Option 2 is $45 for 4 shirts. Option 3 is $30 for 3 shirts. All right? So what we're going to try and do is we're going to try and use these words to figure out what the best deal is using ratio, unit rate, rate, whatever we've got here, okay? So how do we do this? What do we need to compare? What do we need to find? We got to find the unit rate, right? So give me a ratio that I could use for the first one. Well, give me a ratio. Yeah, Jay, what do you got, dude?
25 to 2.
Yeah, so $25 for 2 shirts. Okay, so I'm comparing dollars to shirts, okay, as SH. So what would be, that's a ratio, right? $25 to shirts. That compares two numbers by division, right? It's also a rate, right? I've got dollars and I've got shirts. So what would be the unit rate then for this one? What would I do? To find a unit rate, I need a denominator that's equal to 1. So 25 divided by 2 is the same thing as what? Something over 1. What would it be? 25 over 2. Don't think about it too hard, just 25 over 2. 12.5, right? $12.50. So this is $12.50 per 1 shirt. You guys agree with that part? That's a unit, because I now have a definition of per 1 shirt. Does that make sense why we have a unit rate now? Okay, so now I've got $25.50 or $12.50 for 1 shirt. Okay, give me a ratio that I could write for number 2. Give me the ratio that I have.
$45
I have $45 for 4 shirts. You guys agree with that part? Okay, good. Give me the unit rate now. What would that be? How much? $11.25 for what? For 1 shirt. Okay. Okay, and then finally, I'll give me the option for number 3 there. What would it be? Give me a ratio. $30 for 3 shirts. Okay. And give me the unit rate. What would it be? $10 per every 1 shirt. Okay. So if I'm asking you to find the best deal, which one are you going to pick? Yeah, we're going to do this one, right? We're going to pick $30 for 3 shirts. Now, what allows us to make a comparison between each of the different deals? There's something up here, there's one of these that allows us to make a comparison. What would it be? What would your guess be? Nope, all right, yeah. The unit rate, right? We're comparing the unit rate. We need to know how much one individual shirt costs. That's the importance of the unit rate. We can take any ratio and break it down into its unit ratio. So that would give us, or our units rate, excuse me, that would give us either $12.50 for a shirt, $11.25 for a shirt, or $10 for a shirt. They're all compared for one individual shirt. So it unifies all our denominators. Does that make sense? That's the whole point of our unit rate. Yes. So a conversion factor, the definition that we're going to work with is this. It's a ratio. So it's a comparison of two different numbers. It's a ratio of two equivalent measures, but in different units. So, okay? So maybe if you've heard of conversion factor, but you never actually quite put the definition to work, right? So look, 1 foot is worth 12 inches, right? Everyone knows 1 foot is worth 12 inches. So therefore, because it's a ratio, and because they are equivalent but in different measures, different units, that's called a conversion factor. So 1 foot for every 12 inches, right? Can you guys give me another one that you could think of? Yeah, go ahead. What do y'all? Okay, 2 feet for 24 inches. Right? Can you give me another one that doesn't use inches and feet? Yeah, what do you got? A yard is a yard? Yeah. Yeah, there you go. Okay. Give me something in time. How about time? 60 minutes for an hour, right? So again, ratios, equivalent measures, but different units. That's a conversion factor. Okay, that's a conversion factor. We good with that part? All right, so check this out. We have 330 minutes, and we're interested in how many hours that would be. Okay, so we're going to use a conversion factor. All right, so we're going to start by writing down what we know. All right, we know this. We know that we have 330 minutes. Okay, and we are trying to figure out how many hours this is. Okay, that's what we want to do. 337 is how many hours. Okay, so a conversion factor that we could do is, which one do we want to cancel? We want minutes to cancel, right? We want to get rid of the minutes. So I have to have a conversion factor. Okay, so what conversion factor would I have where I could put minutes on the bottom over here, right? Well, what could I say? We agree with that, right? We could say that this. We could say 1 hour is worth how many? Is worth 60 minutes, right? 1 hour is worth, that's a conversion factor. So this piece right here, this highlighted part, this piece right here, this is my conversion factor because 1 hour is worth 60 minutes. Does that make sense? Okay, good. Now, when I multiply these two things together, look what happens here, right? I'll have minutes that cancel out, right? Okay, and then I'll have the number of hours that I'm looking for, right? So here's what I get. So I'd get 330, and I would then divide by 60, and that would give me exactly 5.5 hours. Okay, so I've converted minutes to hours using a conversion factor. Okay, here's another example. I have 15 kilograms is worth how many grams? Okay, let's start down by writing what we know. All right, I know I have 15 kilograms. All right, so I need a conversion factor, and I need kilograms to cancel out on the bottom. Okay, I need kilograms to cancel out on the bottom. So what do I know? Well, a kilo, it means 1,000, right? So I know that there are 1,000 grams for every 1 kilogram. Okay, that's a conversion factor. So this piece right here, this is my conversion factor right here. Okay, they are equivalent measures but in different units. So 1,000 grams is worth 1 kilogram. Does that make sense? So far so good? Okay, good. All right, so here we go. So if I multiply these two, I would get 15 times 1,000, right? And I would see that kilograms would cancel out and I would be left with grams. So that would give me how much, you guys? 15,000 grams. That'd be good to go. Okay, so check this out. 5 feet 3 inches is how many inches? Okay, so I have 5 feet and I have 3 inches. I want a grand total of inches. Okay, thoughts, ideas? Who wants to take this one on? What should we do? Not everybody wants. All right, well, look, I've got 5 feet, right? And I need a conversion factor, and I want to have feet on the bottom, and I'm going to be left with inches. So what do I know? What kind of convert inches and feet? What do I know? What's an equal? What's a, yeah. Yeah, I know that 12 inches is the same thing as 1 foot. That's my conversion factor. I'm noticing that feet cancel out. So this is just 5 times 12, which gives me how much? That's 60, but look, I also need to add in these 3 inches, right? So if I add in the other 3 inches that I have, I get a grand total of 63 inches. So 5 feet 3 inches in just inches is worth 63. Okay, here we go. I got 1,250 centimeters is worth how many meters? So what do I do? Ooh, do we know this one? Okay, this one's kind of tricky, right? So here we go. So I've got 1,250 centimeters. Okay, I need to multiply something, and I would like my centimeters to cancel on the back, right? Well, centimeters means 100, right? Okay. So so I know that there's 100 centimeters per meter. Okay. So what do I do then? 1 meter is worth 100 centimeters. There we go. So then what would I do? Just take my 1,250 and divide it by what? And divide it by 100, right? So divide it, cancel it, 0, I move it, so that would be what? 12.5? So that's worth 12.5 meters right there. So here it is. So you have a little model car is 7 inches long. The real car is 21 inches long. It's a model of the two. I'm asking for the scale in inches per feet. Okay, see if you can figure it out. Ready, set, go. Try it. Is they say, okay, look, they say that so 7 inches is worth 21 feet. So therefore, what does that tell me? That tells me that 1 inch is worth what? Is worth 3 feet, okay? And you came up with the 3 feet as the 36 inches, right? So you said 1 inch was worth 36 inches, right? But 1 inch is to feet. There's another one that could also work. What else could I say? Dude, I could say 14 inches is worth how much? 42 feet. That's also a scale. It also works. There's a bunch of different answers that can work. But the one that most people come up with is they say, okay, 1 inch is worth 3 feet. All right? But there's a lot of different answers for it, okay?